So I believe most of the customers possibly will be hopefully more than half, slightly more than half.
Actually, there's a Telegram
Not
channel
already
that
submitted
have this kind
for
of
the
events.
assignment one. The assignment one, there's nothing much for me to talk about. So you just look at the assignment and you actually answer accordingly. Right, know that this is the first time that the assignment one
Actually,
is
it's today.
actually
The event is
performed.
today.
So,
Unfortunately, cannot join anymore.
okay, you just answer accordingly. It should be a rather straightforward assignment.
Send the duration for
Assignment 2 is already published. Right again, assignment 2 is pretty short, right? Compared to last time assignment 2. Right, if you have actually looked at just now the assignment 2.
10 February. Used to.
So in your lectures, right, Fusion actually sort of like simplify a number of things. Right, this is the assignment 2. Okay?
How about your
You have a couple of questions to answer. You need to answer all the
almost
questions.
done. PRD. Almost done.
You have followed it.
Great. Just need to type
Right.
some stuff.
3 sentences. Okay. Don't squeeze your words like you put font in or things like that. Assuming that you possibly have font 11 or maybe font 10, I think the smallest. Right, you know, like they want to squeeze more things, then you put font 6 and things like this in the one sentence. Alright, don't do that. Alright, last run, this is actually the assignment 2. You have more questions to answer. So generally it's actually in this form, so but this somehow we actually change this. So again it's an event. So this is like last run. Okay, you have a couple of questions to answer. So, alright.
This one is the ring signature, it's the blue one. Then key exchange ring in the middle.
So this is last run's
I think this one is
assignment 2.
the CD.
Alright.
Yeah, then the C power 0 one.
Okay. So should be should not be that difficult just answer. Okay.
The first one can.
So the other things that I want to highlight is look at the due date. Right, look at the due date. 9 Feb. But it's 8:50 p.m. But be careful of this. Actually, you put an Australian time. Alright, so it's 8:50 p.m. It's not the usual like 2359 or 11. I think they cannot put 2359 because of modem. So it's not the usual 2355 or things like that. It's 8:50 p.m. Alright, so do take note of this. Okay. So submit earlier. In fact, a number of your classmates already submitted, like 12 already submitted. Which I'm not sure if the 12 or you are all here. Okay, they already submitted. So you still have 4 days, right? Still have 4 days. Should be a straightforward assignment, so submit earlier. Okay. So today we are going to discuss the lab 3. I have just uploaded the last 2 labs. Which is the lab 7 and lab 8, the PKI lab and the TLS lab. Okay, so I hope you have set up your seats machine, the Ubuntu seats machine. So what am I going to do is I will load in the Docker file for this particular lab3. The lab3 files is slightly different, right? It's actually slightly different. Okay, this is actually the YAML file. One of the different is it actually have a network port of host. Right? It actually have a network port of host. So what again is actually uses host 10905. It still uses host T10906. The attacker, alright, is actually having a network port of host, so it's actually taking the IP address of your VM, alright, for the attacker. So this is still the network, alright, it's still the 10900. So the whole network is actually 10901, usable IP address to 10901.254, alright, /24, the CIDR location. So it's slightly different, so I will load this, alright, the Docker compose YAML file. I will load this. Okay, again, if you actually look at the model, so each of the lab, right, you look at each of the lab, at least you will have a PDF file, which is actually the lab guide, right, the lab guide. Plus some other files, sometimes, or some other files, and lab setup file. So the lab setup file will include your YAML file that you can load in and start your Docker, right, the Docker container. Because like if you look at lab 4, which we are going to look at it tomorrow, lab 4 actually has more machines, right? Lab 4, you look at lab 4. Lab 4 actually has more machines. Alright, so lab 4 is different. Right, lab 4 is different. Okay. So you have like vector, victims, malicious router, then you have two machines here, 60.5, 60.6 on the separate network. So this is 10900 is one network, 192.168.0 is another network. This is lab 4, which we will discuss tomorrow. Okay. In fact, today actually there are quite a couple of things to do. So my intention is mainly, alright, certain parts of your C programming language. This part can let us set to. We may not be discussing all of them. We'll see how we can actually go. Okay. Then some parts of it, because I've already tested out, I can just post the C code for you, the possibly easier, right, for this part. Okay. So, but then we should be able to go through everything on the Python file, right, the Python file. So if you look at your lab3, right, lab3, there are two parts, two main parts. First part is actually the, first part is the lab asset one. It's a Python using KP, which we have actually done that in the lab 2. Okay? So this part we will spend more time, alright, using KP to spin and spoof backend. The other part is more or less the same thing, but writing in C programming languages, alright, this part. Okay, we may just briefly go through some of this. Okay? And likely there are just post the code, or you can actually use whatever code that you actually have, right, to try out. Okay, the let us set to it. Because some of this is actually the same. So if I use the Python, do some experiments, and use the C programming to do some experiments. So before I start the 6 machines, before I actually started my 6 machines, which you should, let me just highlight certain things for this method. Sniffing and spoofing. So these are two important concepts, alright? One of them is sniff, one of them is spoof. So you need to understand how these tools work. So we are using Wireshark. Last week we have tried, last week we have actually tried TCP down. You have actually done CP, which we are going to continue using it. So this is what you actually need to know. How the sniffing and spoofing works. Using the CP and the PCAP library. Using the raw sockets and the CP. So what is sniffing, what is spoofing? Okay. Then the spoofing part actually requires you to manipulate the packets using the CP, which we have actually done something during the man-in-the-middle access, the ARP pointer. Remember your lab 2, right? The ARP pointer. Just part the reading part that you to read. The lab environment is more or less the same as your lab 2, but we will load in the lab 3 because there's some slight difference. Okay. So we are going to focus on the first set of labs, which is the Python and CP. The second set of labs, we'll see how fast we can go. I'll probably just briefly discuss it, which is using the C programming language. So this is the environment, right? It's pretty similar to your lab. Okay, 3 machines, host A, host B, and attacker. Container setup and command syncing. Basically, you just run the Docker Compose up, you go up. Then you have 3 containers. You can actually use the Docker SH, this is the container that they actually replace it with this Docker exec. Cache ID, right? The particular ID and cache, then you can run the .ps. Just a small for convenience. So again, about the attacker containers, they actually have a shared folders of volumes, so I'm going to use them. So then I don't need to use the Docker CP. Something different for this, that is the attacker is having the network mode of the host. So we use the host mode. So this allows the attacker to see all the traffic, right, the host. So it actually has the same IP address as the host. So it will assume this IP address of like 10901 for the attacker. But it's still a separate machine. Okay. So I'm going to put out my seed machines. So I hope you have already installed this. Okay. Let me start up. more than half here. So I guess this will be sort of like consistent until yeah, 8. Okay, there's something that if you want, right, if you want, you can actually install. It's actually called Terminator. Right, if you want to install the Terminators, you need to update first. Run the sudo apt update. Okay, you don't have to upgrade because that's going to take a long time. So if you want to no, I suggest you actually don't have to upgrade because it's the C computers and you only use it for this mod. So if you want to install the Terminator is something like your terminals, but it can actually help you to split the script. So like we can actually split our shell to like 4 or 5 windows. And so at one glance you can actually see the overview. Okay, rather than you create new windows and new tabs. So if you want to install it, you can actually run the sudo apt install Terminator. Mine's already installed, so it's pretty fast, but yours possibly will take a little bit of time. Alright, this is not necessary, this is up to you if you want to use this. Because you can actually use the terminals, it's actually not needed. But it's more for convenience. Right, so the tool, the name is actually called Terminator. After that, you just have to switch it on. Right, so usually what happens is I go to Activator. I will open up this Terminator. Right, so this is how it looks like. So I can right click things like I can, okay, I should go to the path first. Right, so this Terminator, like, okay, I do something, then later you can try it out. You can right click split horizontal, right click split vertical, so you can put your containers in different tabs and things like that. Okay, again, this is not needed, this is more for convenience. Okay. So what am I going to do is I will use the shared folder to share my net tree, right? To share my net tree that setup. confirm this is the correct YAML file. Okay, yes, the getter point is closed. So this is the correct file. And what I will do is I will go to the, okay, I'm just loading the correct app setup to the seed machine. I'll use the UI, alright, the file. For me, usually what I do is you can either run the commands, the mount commands, or I can just click on my shared folder. And it looks a bit hang. Let me just Maui. Okay, note that mine is actually called seed, that's why. Alright, actually here the left setup. So you just copy the modules and the Docker Compose. Okay, my folder I write that 368 maybe different from yours. Copy it. Okay, so you got to be in your folders, right? Alright, in your folder, don't use the shared folder between your Windows and C Ubuntu. Okay, then I right click, open in terminal. Make sure that your Docker Compose is here, or your volume is here. Actually, can you see it? Okay, should be all right. So just run the Docker Compose task. I'm actually going to use the terminator. If you don't have this, also doesn't matter. You just use the terminator to write the default terminator. Right, I'm going to go to the correct folder. Remember your folder and my folder may be different. The folder that consists the Docker Compose files, the YAML files. Yours and mine will be different. Right, shift Control plus to make it bigger. Right, I think let me just run this command. If your left, usually I don't run this, but I think this one is clean. Run the .ps. Okay, when I run the .ps, I will have the container ID together with the container name. Alright. Yeah. Because I'm running the terminators, I can actually split. So I right click split horizontal. You may not need to do this. If you don't have this, you just go to your terminals, you just right click and new text or new window. Right, it's up to you. I just want to show you at one glance so that it's possibly easier, right, to see. I'll split horizontally. Okay, so let's just split. Okay, this is just vectors. Alright, and below I actually split vertically. Then I run the .sh. Right, I'm actually following the lab guide here, or slide 3. Lab 3, slide 3. Actually, every lab will have the environment set up. And use the short form, alright, the .sh. So I go to A7. A7 is actually the, for my case, yours will be different. It's my N905. Okay, N905. Then on here, I split another terminus with it. Split horizontally. So now I go to my N906, the 3N. Okay, so this is my N906. Then the other side, so I have 05 here. Alright, I have .5 here, I have .6 here. Then I'm going to do my string actor, which is 466 for my case. So this 66 is actually the 10901, right? 10901, which is the actor machine, having the same IP address as the VM, the Ubuntu VM. Okay, I'm here just setting up the environment. I haven't actually done anything yet. Because I noticed, especially some of the later labs, you get to open up quite a number of windows on that. Right after a while, it gets confused, right? This one possibly cleaner. So if you want, you may want to install it. use this, right, to use this, you have to install Terminator. Right, again, the two commands that you use is just to sudo update, sudo apt updates and a sudo apt is install Terminator. Okay, in case for some of you that actually want to install this, but you miss the part discussed on this, it's pretty easy to install and use it. Right, don't need to upgrade, just update, so don't upgrade, just update. If you want to upgrade, you probably want to go back home and do it. I think the network is not that fast here. So I will look at the task. So let's look at it. So we are at your lab guide, alright, your section 3, net task set 1, using Scapy to sniff and spoof packets. Right, in fact, this part we have already done similar things. For this one, many tools can be used to do sniffing and spoofing, but many of them have fixed functionality. That means you can't customize, or you can't actually do certain things that you want to. Scapy is a building block to construct. You can actually use Scapy and use it actually in Python, and you can actually write anything you want. So we have actually already done it in the lab. So we are going to write a Python program. Actually, you don't have to run this because last lessons we have already done something like this. Alright. You need to run in Python using the root privilege because this is actually required if you actually want to spoof packets. One very important thing is you need this line from scapy.all import if not, then you will not work. You need to import. So this one I'm not going to run this again because we are having something similar in the lab 2 before. My suggestion is you use Python. Use Python instead of making it executables and actually run it. Okay. Use Python. Again, Python 3 is just I leave it to you to try out. I'm going to zoom into your first task, right? Sniffing packet. Okay. So here, besides writing the code, we are going to use Wireshark also. So this is a piece of code that you can actually try, right? At task 1.1. You can just copy this whole code. Bear in mind that you need to change the interface. Right? You may need to change the single code here. Right? This may not work, so you change it again in the single code. Right? You can actually copy this whole code. So here, you don't need this one. Okay. Oh, I missed out the hash. Right, change it to the single codes that you have. This one's causing your problem. Remember to change your interface, alright? Everybody will be different. Alright, everyone will be different. So how do I actually get this? I go back to my Academy machine. You see just now I actually have the, okay, I cannot grab, I just going to use the I config. I just grab the VR or VR dash, so copy this, hold it. Right, this is actually in your Academy container. Just copy this. The interface names of VR, right, paste it here. Right, remember you need to change this, right? If not, it will not work. Right, this one. The VR something in the interface. How do you get it? Again, you go to your container. You run config, you look at the VR dash something, or you just grab VR dash. Things should be just one line. Yeah, you grab VR dash, those things will come up. Just like the VR something. So everyone will be different. You got to use your phone. All right. This is your Academy container. Okay. So this piece of code that is given to you, which I'm actually in task 1.1, 3.1, section 3.1, task 1.1, this I'm actually in lab 3. Right, help each other, some may just come and maybe something. So I'm actually copying this piece of code. Alright, so this piece of code actually allows us to sniff, right, actually have a sniff function, making use of a skippy. Sniff the interface, the VR interface, which is actually the Docker's container interface. It actually put a filter. Okay, I missed out one semicolon, right? Right, it actually only sniff the ICMP packets, right? Only ICMP, because the filter is ICMP. Then the PIN actually calling the split, no, sorry, I forgot the indentions. Right, in the indentions, the packet, alright, not show, right? So it will show the packet. If you actually do ICMP, it will show the packet. If you do telnet, it will not show. Okay? That means you ping, you will display the packet. If you telnet, you will not display. Alright. After that, I'll just copy this. In here, right, in the top, I will just open up another text. So I will split vertically. Alright, I will do lab 3. This is task 1.1. So I put lab 3 task 1.1. .py, right, .py. Enter, I use gedit. Copy it here, just a piece of code, save it. Okay, so hopefully after lab 2, you are getting more familiar with the environments of the Docker and so on. We are not using any command from Docker. We just need to bring it up. And we just need to go inside each of the container and run our task. Okay. So after I save it, what I can do is I can actually straight away run this. I will copy it in the volume. Right, if you ls, you notice that I actually have the volume folder. Okay, I'm actually doing the same thing as what I did from the lab 2. The lab 2 I actually open up a number of tabs. I think that will be a little bit confusing. So this time I'm using the terminator. So at one glance, okay, this is my seed computer. This is my seed computer, right? This is host A, this is host B, this is the attacker container. Alright, host A container, host B container, attacker container. So from the seed machines, I copy this files to volume. So if I ls volumes, I can see the Python file there. Then I can run it straight in the attacker container. Attacker container also have a volume, so I cd to that, right? Cd to that. Then just run. Right, Python 3 let 3 p11. I run it. Then after that, alright, I'm going to turn on my Wireshark. Right, my Wireshark. In the Wireshark, it has a numbers of interface. I was turn on the BR cache, alright, that particular interface. Double click on it. Go back to the terminator. From host A, ping host B. Just send one packet, so I use the -C1 ping. Then once I ping, you can actually see that in the attacker containers, I can actually see the details, right? The internet details, what is the destinations. Notice that in the SIGLab, they actually set it pretty clearly. Alright, so IP address .6, they have the MAC address at 06, IP address .5, the last byte 05. So this is the IP header, right? This is the IP header. The versions, the TTL, the protocol is ICMP, source IP address, N905, ping N906, which is destination. And for the ICMP, right, they actually have like the path. The path is actually echo request. Alright, code is 0. This is the sort of like a payload, right? The load. Then at the Ethernet layers, that's the IP. Okay, after the ICMP, you actually have all this. Oh no, sorry, this is another packet. Sorry, this is another packet. This is the ICMP echo reply. Alright, so you have the echo reply. Okay. Just send one packet will do it. Send a lot, sometimes very confusing. Go back to Wireshark. Ignore the ARP. You will see you have a 10905, ping 10906, 10906 reply. Okay. Right, so can the limit for echo request, echo reply. Right, echo request, echo reply. But if you do telnet, right, now I'm going to stop this. Control C to stop this. Right, run curl to clear the scripts, right, on the container, attacker container. I use the up and down arrow key to toggle the command. Run the Python 3 code again. Do telnet. Right, do telnet. You see that this time it actually doesn't display because the filter is on ICMP. Okay, the seed password is DEES. Alright, again, it's the old style. You type the password, it will not show you star, things like that. Right, just hit enter. Okay, type in, hit enter. Go back to Wireshark, you have a number of like telnet traffic. If you click on any of the telnet data, right click, follow TCP stream, you can see the login name, or it's the echo, so you have the S2 times, so it's SEED, password is DES. Okay. But go back to your program, the program didn't display anything. Right, so it's correct because you filter by ICMP. Okay. So this is your task 1.1. Alright, let me go back here. So I exit. I click again, take another packet again, you'll see that that's what I actually showed. Right, this was the container, this is host A, host B, container, echo containers. You will show the echo request and the echo reply. So far so good. So I'm already doing task 1.1, I haven't actually moved on. So for those that have done your 1.1, this one I leave it to you to try out. Okay. So you have already done this, demonstrate that you can keep captures packets. After that, run the program again, but without using the loop replay. Describe and explain your observation. Right? That's what I leave it to you. You can ask you to see that you run it. You'll not be able to run and you have to keep forward. Okay, the PR address is right. Let me show you again. I have config. You must be in your seed expected. I have config. Just run I have config. Or you may want to grab PR dash. PR dash. Okay, if you are running the lab2 Docker Compose, they have problems because now I notice the lab2 Docker Compose is having the IP, the active machine is having an IP of 105. Right, then you don't be able to capture because you need just if you look at the Compose file, you need to run the lab setups YAML file this one in your lab tree. You cannot use the lab 2 one, right? In lab 3, you have the network code, you need to for that vector. So you assume the IP address is 10901, and you'll be able to sort of like capture all the traffic. Yeah, so if you are running the lab 2 run, right, you load in the lab 3, so that means you Docker Compose down. Okay. Stop all the containers running for your lab 2, then you bring up the lab 3 Docker, bring out the lab 3 lab setup, then you have it on. Okay, so from now on, every lap you will have to stop the previous lap, the container, right? The container from previous lap. Then you've got to bring up the containers for the current lap, right? You don't have problems. Get it? As an example, if you want to go from lap 3 to lap 4, maybe you have to Docker compose down, right? Check that your containers are all removed. Then you bring in the newer lap, right? The YAML files, then you bring out the Docker compose out. Right? If not, we'll have problems. Let me just talk about so far any issues so far. Because some may have problems getting the environment set up. Okay, for using of certification, right, you may not need to follow me, right? Because this is my style. I put a things like example, I put a containers, the affected containers on the right side, right? Things like this. I put it on the right side. I put the seed machines on top. You use your own way, as long as you know which container is which container. Because after a while, it can get very confusing, especially if you have several containers. And one of the common mistakes is using the wrong container to do the task. One of them is using the wrong container. The other one is didn't change the interface, alright, the DI interface. But forget to change the DI interface. Okay, again, the task 1.1 here, I leave it to you to try out. You can ask you to sit, then you run the same thing again. Run a Python again, so you can actually run a very quick one. Right, ask you to sit, Right, you notice you will get errors, but it's actually operations not permitted. Right. You can't run them. If you use root, you are able to run. Okay. Okay, so those that have already done, alright, you're going to try your task 1.b first. Task 1.b is actually the same thing. Alright, but first thing, this one we have already done. Alright, capture only ICFT packet, which is the filter, this one. You can actually try out this part, which I will do it right in a short while. Alright, capture any TCP packet that comes from a particular IP address with a destination port number of 23. Alright, so from a particular IP address, that is the source IP, specific IP address, possibly maybe N905 or something like that. Destination port number 23, what is that? Telnet, alright, Telnet. So only, if you do that, so that means you only snip, alright, the packet from N905 that is going up to any other machine, alright, with using Telnet. Copy to is Telnet. Or you can, then after that, you can actually capture packets come from or to a particular subnet. Right, the snipping code you run it in your attacker, right? The container attacker. Okay, the attacker should have the BR, right? Attacker should have the BR. So attacker prompt actually looks like this. It looks like this. This is the attacker. Okay, sometimes how do we know that we run it in the wrong container? Because your host A. Host A actually have like the container ID. This is the container ID. Host B also have a container ID prompt, right? The prompt. In attacker, alright, you have a prompt of like TX. Alright, root at TX. So it's root at the yeah. Okay, the reason why I CD to the volume is because the attacker container actually shares this folder with your Ubuntu VM. Alright, it actually shares the folder. So whatever things I put inside the volume, I show you in the UI. Whatever things I put inside the volume, I will be able to see it in the attacker container. So I don't need to use the docker cp command. If not, you use the docker cp, but it will work also. Alright. So in here, because I'm already, this is my hectare container. Alright, I will have the file there. Okay, the reason is that usually when I do the pin, I just pin one packet because when I look at it in the Wireshark and in the sniffer program, it's easier to see. I know that you just send out one packet and just get one response, easier to see. Okay, to run Telnet, this one is actually my dot file. This is my dot file. You just Telnet to .6, right? Or from .6 you Telnet to .5. Alright, so this is just the Telnet command. Alright. Login, seed, SEED, password, DES, right? The same as your Ubuntu here. Let me show you like how this works. Right, you can actually do this one. Right, the filter, you go to TCP and let me just copy this first. Okay. Let me try first to see that this is okay before I actually show you the code indicator. Okay, so this is actually this part. it actually captures any TCP traffic, so the filter is TCP. Right, do an N. Source host, or source host I put as 10905, right, from a particular IP with the destination port number of 23, right, and destination port 23. So TCP and the source host 10905 and destination port 23. Okay. This button. Yeah, the rest of the code are the same. It's only a filter. So what will happen if I do this filter? The program only only shows TCP, which is actually when you actually do the testing from your .5, you telnet to .6. From .5 telnet to .6, you'll be able to see the traffic. If you do the reverse, .6 telnet to .5, you will not be able to see, right, the display. You just do a quick one. If I do the reverse direction, right, I will not be able to display. Okay. So something that you can try. Alright, again, this is the code. Basically, just this button. Okay, for the bodies folder, because of the YAML file that is set up, only the attacker machine has the body. Your host A and host B do not actually have a body folder. So you will not see there's no body. So let's just try out this part. Right, again, what is the effect of just this? You will be able to capture the traffic from when you actually do a telnet from 10905 to 10906. You will be able to see. Right, because the source code is 10905. Then the destination point is not 236 telnet. But if you do the reverse, if you telnet from 10906 to 10905, you will not see it. And because we didn't capture the ICMP, which is the ping, so if you ping, you also would see the traffic. Alright. So let me just stop a while. Okay, most likely we may not touch a lot of, or maybe we don't even go to the C program and see how is it. And I can just run a quick one to show you. Because the C program, mostly the tasks are more or less the same as a Python. Alright, so those that have already done, you can actually move on to your task 1.2. Task 1.2, then your task 1.3, and your task 1.4. So today, at least we have covered the sport. Actually, this one not really that important. More or less the task about the same. So let's talk walk around anything just let me know.
Yeah. To 3:30. Yeah. What? No. Yeah. Yeah.